Good day, students. Welcome to the 2014 AP Calc Review. We're going to be going over problem number 3 on the AP exam question. This question focuses mainly on graphs of f prime, and f double prime, application of the chain and the quotient rule, and the fundamental theorems of calculus. Don't forget to visit math.serve.com for a wide variety of math tutorials. And if you need the remainder of this review series, go under AP Calculus and math.serve.com and you gain access to the rest of this review installment. So let's take a look at letter A. We have to find g of 3. So we need to determine what the function g of x is first and evaluate it when x equals 3. So g of x is provided for us. It's the integral from -3 to x of f of t dt. So what is g of 3? Well, that simply means you just input 3 into x, okay? Because x is equal to 3 here. So we have the integral from -3 to 3 of f of t dt. Okay, so what is the connection between the definite integral and the graph of a function? Because we are provided with the graph of f here. So what's the connection between the definite integral and the graph? Well, the definite integral represents the area between the function and the x-axis, right? So for this situation, we're going from -3 all the way to 3. So the question is, what is the value of the area between the function and the x-axis on this domain? Okay, so we're going from -3 to 3. Let me graph the end point right here. There you have it. So if you examine this region, what you find out is that we have two triangles here, okay? The first triangle, let's call it the blue triangle. It goes from -3 to 0. I'm sorry, from -3 to 2. I'm stopping there because this triangle is above the x-axis, okay? So this blue triangle right here, let's call it triangle number 1. So triangle 1 is this entire triangle here. The second triangle that's captured in this integral goes from 2 all the way to 3. So let's call this triangle 2. And it's basically this region right here. All right. So this definite integral can be expressed as follows. It's going to be the area of triangle 1 plus the area of triangle 2. So we'll find the sum of these two areas. That will be the definite integral from -3 to 3. Okay, so these are familiar geometric shapes that we can easily compute what the areas are. Remember what the area of a triangle is, right? So from elementary geometry, we know that the area of a triangle is 1/2 base times height. For triangle 1, we know that the base is, you're going from -3 to 2, so that's 1, 2, 3, 4, 5 units. And the height, the perpendicular height from the base, is 1, 2, 3, 4. All right. And then for triangle 2, the base, you're going from 2 to 3, so that's 1 unit. And the height, how low do you go from 0 here? Well, we don't know what the coordinates of this point is, so to figure that out, we can simply take advantage of the fact that this is a straight line and determine the slope of this line. So what's the slope of this line? You're going down 1, 2, 3, 4, 1, 2, so basically -4/2. So the slope of this line is -2. All right, so every time you run 1 unit, you're going to drop down 2. So if you go back, if you run 1 unit, how many units you drop down? -2, okay? So the coordinates of this point is basically 3, -2. So that follows that the height of triangle 2 is, you gotta be careful here, -2. It's negative because we're going downwards beneath the x-axis, all right? So we have all the information we need. Let's go ahead and input it into this formula here. So the area of triangle 1 is going to be 1/2 base of triangle 1, which is 5, times height of triangle 1, which is 4, plus for triangle 2, same story, 1/2 base of triangle 2 is 1, and the height is -2. If you work this out, you have 20 over 2, which is 10, plus 2 goes here, 1, 2 goes here, 1, -1, times 1 is -1. So 10 plus -1 is +9. So that's the value of G3, G of 3, okay? All right. So let's take a look at the B part. The B part says that on what open intervals contained in -1, -5 to 4 is a graph of G both increasing and concave down. Give a reason for your answer. All right, so whenever we're connecting a function with its derivative and its second derivative, I always like to make use of my differentiation sign part, okay? So what on earth is that? So let me show you what I'm talking about. So let's say we have a function, its derivative, and its second derivative. These are connected, okay? So let's look at the sign. F prime could be plus or minus. Second derivative could be plus or minus. All right, so the first connection is by the first derivative, like that. And then you also have a connection between a function and its second derivative, like that, okay? So the first layer of connection in just the first derivative tells us if a function is increasing or decreasing. All right, so increasing, decreasing, increasing, decreasing, when one step is just a derivative. So what this tells me is that if f prime is positive, f is increasing. If f prime is negative, f is decreasing. And then the same rule applies to connecting f prime with f double prime, all right? So what connects f and f double prime? Well, it's the concavity. If f double prime is positive, f is concave up. If f double, let's write that down again, kind of looks like a D, concave up. And then if f double prime is negative, then f is concave down. Okay, so that's the connection here. So what we're going to do now is I want to connect, we're talking about G, I want to connect G and F, okay? So we know that G of X is equal to the integral from -3 to X of f of t dt, okay? So what is G prime going to be? G prime of X is, using FTC part 2, is going to be the derivative of that, which is basically f of X. And then G, so this is G prime. And then the second derivative of G is going to be f prime, the first derivative of f, because we're differentiating this, okay? So these are the, what I'm going to be using in my chart. So let's go ahead and I'm going to recreate my differentiation sign chart and apply this problem to the situation, okay? So we're dealing with G here, okay? G prime, remember G prime is the same thing as f, and G double prime is the same thing as f prime. All right, so we're going to be connecting these. I'll draw my nice little heart here. All right, so when these are plus or minus, that means G is going to be increasing or decreasing. When these are plus or minus, that means G prime or f is going to be increasing or decreasing. All right. Now when G double prime, which is the same thing as f, is positive or negative, that means G is going to be concave up or concave down. All right. So for this problem, we're told to find the intervals where G is increasing and concave down. All right. So let's look at it. G is increasing. G is increasing. Which connection is increasing or decreasing? It's just one derivative, right? So G is increasing when G prime, which is equal to F, is what? positive, right? Or greater than 0 when they're positive. And G is concave down. Now, what is the connection with concavity? Concavity has to do with the second derivative, right? This concave down when G double prime, which is equal to F prime, is negative. All right? So these are the two conditions. So what we're going to do is we want to look for the intervals where G prime is positive and G double prime is negative, or where F is positive and F prime is negative, okay? So what I'm going to do is I'm going to represent this situation with an ordered pair. All right, so let's call the first input in an ordered pair G prime, which is equal to F. Since we're using this graph, we need to work with F, okay? And then the second input in our coordinate pair, G double prime is equal to F prime. So we're looking for when G is increasing, which means G prime is going to be positive. And when G double prime, which is F prime, when G is concave down, which follows that G double prime is going to be negative. So what I'm going to do is I'm going to take a look at these intervals, and I'm going to determine the sign of the first derivative of G and the second derivative of G. All right? So let's go ahead and do that. I'm going to break it up in such a way that you can really understand what I'm doing. So this is the first interval. This is the second interval. And this is the last interval. Now, how do I know where to break? Well, I'm breaking the points where either F prime or F where F or F prime changes sign. Okay? So in this point right here, the derivative changed from negative to positive. All right, and then here it changed from positive to negative. But here, the sign of F changed from positive to negative. All right, so that's my criteria for breaking this down. So I'm basically breaking the critical points and the zeros. Okay, so that's the reality here. All right, so now in this first interval from -5 to -3, what are the signs for that? The function is going down, which means that this F is, well, let's do the sign first. Remember we said the sign is, we said F is the first input and then its derivative is the second one. Okay, so what is F here? F is positive since it's above the x-axis. Since it's decreasing, is negative. Here in this interval, the function F is positive since it's above the x-axis, and its derivative is positive since it's increasing. For this interval, F is positive since it's above the x-axis, and its derivative is negative because it's decreasing. And then for this last interval here, from 2 to 4, the function is underneath the x-axis, so it's negative. And since the function is decreasing, the derivative is also negative. So what we're looking for is a plus and a minus, a positive function where the function is positive and where it's decreasing or has a negative derivative, plus minus, okay? So what intervals satisfy that requirement? This interval is good, this interval is good, the other are bad. All right, so that's basically what our answers are. Let's go ahead and write down what our answers are and the reason. So our solution, G is increasing and concave down on two intervals on -5 to 3. Well, let's use, yeah, -5 to 3, -5 to -3. Union, what was the second one? Go up again. So it went from -5 to -3, and also 0 to +2. union 0 to positive 2. Why? Because um, because G prime is positive, which means it's increasing, and G double prime is negative on these intervals. Alright, so this is the explanation why our answers are what they are. Alright, let's take a look at question number C. It says the function h is defined by h of x equals g of x over 5x. Find h prime of 3. So this problem involves using the quotient rule. Okay, so h of x is equal to g of x over 5x. So h prime of x is just the derivative of this rational function we have here. Alright, so before I differentiate this, let's go ahead and review the quotient rule real quick. U over v prime is equal to v u prime minus uv prime over v squared. So in this problem, the numerator function is your u, and your denominator function is your v. Alright, so let's go ahead and apply the quotient rule. So v is 5x times the derivative of the numerator g prime of x minus u, which is g of x, times v prime, the derivative of 5x is just 5, divided by the denominator squared, which is, let's see, 25x squared. Now, if you notice, 5 is common to all three terms, so we can divide by 5. 5 goes here 1, 5 goes here 1, 5 goes here 5 times. So what we have is x times g prime of x minus g of x over x squared. Alright, so let's see, what can we do here? Let's say over 5x squared. Now what is g? So what we're going to do is take full advantage of the situation that we know what the antiderivative of g is. So if we have g prime is the same thing as what? Remember, we talked about this earlier. We established a connection that we said that if g of x is equal to the integral from -3 to 3 of f of t dt, using FTC part 2, g prime of x is what? F of x, right? We established that earlier. So this is going to is the same thing as x times f of x minus g of x over 5x squared. Alright, now we found the derivative. Now to finish this off, we just have to evaluate the derivative at the specified point. So let's go ahead and do that. So we want to find h prime of 3. So we're just evaluating this expression when x is equal to 3. So we have 3 times f of 3 minus g of 3. That divided by 5 times 3 squared. Okay, so times 5 times 3 squared. Alright, so let's see what this is going to be. So we have 3 times f of 3. We had already determined that earlier. When x is 3, what is the y? What is the output? Remember, the slope of this line is -2, right? So this point we already said earlier was 3, -2. So our output there is -2. This traces perfectly to here. So we have f of 3 is -2 minus g of 3. We had calculated that earlier, I think in part A, as 9. You basically plug in 3. You just evaluate this integral right here, okay? So let's see. I'm gonna make a real quick correction here. That should be x. So make this x. Okay, so we know that piece. And then divided by the denominator is 5 times 9, which is 45. And then if you work this out, negative 6 minus 6, negative 15 over 45. And your final answer is negative 1/3. All right, let's take a look at the D part. It says the function p is defined by p of x equals f of x squared minus x. Find the slope of the tangent line to the graph of p at the point where x is equal to negative 1. So this is a very straightforward problem. You just have to remember that the slope of a tangent line at a point is the same thing as the derivative at that point, right? So what we're just looking for here is we're supposed to find p prime of negative 1. That's all we have to find, okay? So to do this, we have to find the derivative of the function first, of course. So the function is this composite function right here. So if you're differentiating a composite function, we have to use a chain rule, all right? So if we differentiate this using the chain rule, we differentiate the outside fix. We differentiate the outside function, holding the inner fix as x squared minus x times the derivative of the inner function. Okay? Remember your chain rule. If you have f of g of x prime, this basically becomes f prime of g of x times g prime of x, right? That's what we're doing here. Okay, so this becomes f prime of x squared minus x, and then if you do this term by term differentiation, times 2x minus 1. Now we have the derivative. We're going to evaluate it at a point, namely negative 1. So p prime of negative 1 is going to be f prime of negative 1 squared minus 1 times 2 times negative 1 minus 1. All right, so if you do this, this is positive 1 plus 1. So we have f prime of 2 times minus 2 minus 1 is minus 3. Okay, now we have f here. So what is f prime of 2? F prime of 2 is basically the slope of this line, right? The slope of the line at 2. We already determined that the slope of this line is negative 2 earlier. So you're just going to plug it in here. F prime of 2 is equal to negative 2. And then negative 2 times negative 3 is equal to, positive 6. All right, so that's that. So thanks so much for taking the time to watch this presentation. Do feel free to subscribe to our channel for updates to the remainder of this review series and other great math tutorials. And do post a comment to let us know what you think about this clip. We really appreciate it. Thanks again for watching, and have a wonderful day.